Yes, hello. My name is Migo Jean de Dieu, chemist teacher at College Dek Ruhanga. Now we are going to deal with the unit 1 in Sinafo called atom structure. Then, in atom structure, yes, you have some key points you have to know. I would like to call every person to be attentive for this time. Before I'm going to see that in unit 1, this is the question I have to think after running this topic or this lesson. Yes, the question, yes, define the following term: atoms, element, compound, isotope, mass spectrometer, relative atomic mass. Yes, explain stage or stages of mass spectrometer. Explain 5 functions of mass spectrometer. Who discovered proton, electron, neutron, and explain clearly their discovery. This is the question you have to answer after studying this unit. Yes, I'm going to start unit 1. Unit 1. What is atom? Atom is a basic unit of element and compound, whereas element is a substance that can't be broken down by ordinary chemical method in simpler substance, whereas compound is a substance formed by the combination of 2 or more different elements in a fixed ratio. This is the definition. You understand? Try to repeat it. Try to write it. Try to take the key point. Then this summary. Then the isotope. What is it? Isotopes. Isotope is an atom of the same element. Yes, of the same element with different masses, with same proton but different number of proton. Example, we have first we have X like this. We have X. This X have let us assume that it is at 12. Example, this is we have 8. Example, take this. Also, this is the X again. Have 24. Example, and 8. This element, let us call is element, and also this is element. According to this element, those elements are isotopes. Why? Because they have the different. They all are the same element. Are the same element. Yes, are the same element. Yes, are the same element. Or X and X, but the mass are different. These mass are different. Also, this atomic number is the same, but mass are different. This is the isotope. You understand? Then, what about, yes, in the nucleus we have a proton and a neutron, and mass number is equal to proton plus neutron. You know the formula of yes, we have this Z. If you have like this. This is the atomic mass, whereas this is the atomic numbers. Yes. Then atomic number, yes, A is equal to mass or mass number is equal to proton plus neutron. Then explain for Dalton's theory. Yes, the first one, elements are made up of tiny particles. Atoms of a given element are identical. Atoms of a given element are identical. Chemical compounds are formed when atoms of different elements combine with other. Then the chemical reaction involved the reorganization of atoms, or atoms themselves are not changed in a chemical reaction. This is for Dalton's theories. Yes. Then the discovered proton is Rutherford says that atom, yes, the mass, the proton are concentrated or are located in a nucleus. In a nucleus, first is we have this. We have this proton. Here we have this is the nucleus. Then, according to the Rutherford experiment, they found that the proton are located. Yes, proton are located. This proton are located in the center of nucleus. yes, proton are located in the center of nucleus where the electrons are surrounded around nucleus. This is the where the electron, where proton are located in the center of nucleus. Then when we discover neutron is Chadwick, discover for electron is Thomson. Yes, is a Thomson. Here in your exercises book, in your free time, try to read this experiment. This is the discovery of this proton, electron, and neutron. Yes. Then a proton, yes, who discovered proton is Rutherford by using Godefroy experiment or probing atomic model. By using Godefroy, they found that most alpha particles travel in a foil with unreflected. Why? Because atom has empty space. Yes. Then later, also some particles deflected at a small angle. Why? Because the nucleus has a positive. Yes, you know, because if you have, for instance, if you have a atom like this atom has this proton in the center. If there is alpha particles move, they move like this. They move like this. They move like this. Also, there is another. These alpha particles they deflected. They deflected. They deflected. This is the alpha particles. Alpha particles. Yes, this is the alpha particles. Yes, as you see. Yes. Ahangaha muri nucleus niho proton ziri, naho aho none hano urabona alpha particles yagiye igenda igapasa muri atoms. Ni kigaragaza ko hano hari empty space. Ngiye twavugaga ngo most alpha particles travel in a foil with unreflected ntaganga yabaye deflected yahise passing. Why? Kubera ko atom ifite empty space. No, some particles deflected at small angle. Kubera iki? Zimwe rero zagiye zisi hano yakoze deflected kuri small angle kubera ko iyi alpha particles muri nucleus harimo positive. Yes, like alpha particles. Then ahangaha some particles travel back. Hari noneho yakoze back. Yes, hari urabona iyi yakoze back, yakoze back. Ntabwo yagiye ngo ipasinze ahubwo isikora back. Why? Because the mass are concentrated in the nucleus. Yes, mass are concentrated in nucleus. Also, electron orbit the nucleus like a planet. Anga bavuga ngo electron ziri kugenda kuri ntuza kuri orbit ziba ziri kugenda nkuko nkuko planet biri kuzenguruka iki izuba. Ahanga electron biri kumuvinga ahanga on this atomic orbitals like this and like this. You will see in the following slide. Yes, let us see Godefroy experiment. Rutherford Godefroy experiment. And with the source of radioactive source. You see, this is the source. Then in the beam of light of particles, then is moving as zigiye kwi Godefroy. Godefroy urabona ko hari amarays gagiye passing agahita. Ayanga gagiye passing niyo bavuze ngo most alpha particles travel through foil and under deflected. Ahangaha ntago zabaye deflected, zahise muri nuza muri Godefroy. Kubera iki? Kubera ko atom ifite empty space. None hari izindi zagiye zidevia muri angle. Yes, angle ntoya cyane zikadevia. Kubera iki? Some alpha particles are deflected. Zimwe zagiye kwa deflected by small angle. Why? The nucleus is a positive. Muvuga ngo muri nucleus harimo ki? Harimo positive. Yes, hafite ntuza in nucleus we have in nucleus we have a positive. In the center, we have a positive. Reason why they deflect at small angle. They deflected at small angles. Yes. Do you understand? Then ahangaha naho hari noneho hari nuza yagarutse yakoze comeback. Hari rays yahisigaruka kubera iki yagarutse. Occasion an alpha particles travel back yakoze back yagarutse from the foil. Why? The nucleus carry most atom mass. Nuvuga ngo hano muri nucleus biracha bivuga ko ahangaha muri nucleus dufitemo ntuza dufitemo positive, dufitemo ama positive dufitemo charge ziri positive. Bigaragara ko nigera hano kuri ntuza n'ibingi ari alpha particles kagenda igakora back, ni kigaragaza ko dufitemo positive ziri concentrated nucleus. By conclusion yahise avuga ko ubwo comment point observation is ingi observation ya mbere ni ingi ya kabiri ni iyi ya gatatu ni ingi and the reason is this is the Rutherford Godfrey experiment. Do you understand? I think that you get something. Do you understand? Do you understand? Yes or not? If you have a question, ask. Yes, although this is the Rutherford also experiment about that model. Ahangaha ukubona ko yakoresheje alpha particles zimwe zagiye zimuvinga. Yes, zimwe urabona hari alpha particles, zimwe alpha particles. Yes, ahangaha dufite alpha particles. Yes, this is the alpha particles. Noneho hano urabona ko zagiye zikapasinga muri ntuza, zagiye zikapasinga muri atom. Yes, electron urabona ko ahangaha ziba ziri muri ntuza ziri embedded in nucleus. Noneho urabona ahangaha hano ko muri ahangaha ni muri nucleus. Yes, ahangaha ni muri nucleus. Yes, ahangaha ni muri iki? Ini nucleus. Yes, ahangaha ni muri nucleus. Ho alpha particles yakoze reback kubera ko positive ziba ziri concentrated in nucleus. Ahangaha urabona ko impamvu zagiye zipasa ahangaha ni muri empty space. In empty space. In empty space niyo mpamvu alpha particles yagiye passing. Yes, noneho ahangaha Rutherford yavuze ko rero electrons ziba ziri embedded in nucleus. Yes, ziri surrounded. Noneho aho positive ziba ziri in the center. This is the conclusion of Rutherford about atomic models. Yes. They also have atomic model of Rutherford. Also Rutherford, the Rutherford models, they concluded that the positive, the electron are concentrated, are located in proton are located in the center. Here you see this proton in the center where the electrons are revolved around like this only, or this is the orbit. Also this is the orbit. Hanga electron biri kugenda kuri intuza hanga nabavuze ngo electron zazi kumuvinga nkuko sun biri planet biri kuzenguruka iki sun. Hanga izi ni electron kuko electron ifite charge positive, ifite charge negative. Hanga ifite charge negative ni electron noneho zazi kumuvinga kuki kuri orbit. Yes, ingini. Yes, in orbit. In orbit, where electron move in orbit, in orbit. Yes, this is what is the models? Planetal models. These are planetal models. Positive charge is concentrated in the center, as you see. This is in the center. Positive charge in the center. You see. Yes, the atom called the nucleus. Yes, and the nucleus also electron orbit. The electron orbit the nucleus like a planet orbit. Anga avuga ngo electrons zaziri kugenda nko planet zazi kumuvinga kuri suns. This is the Rutherford model atoms. You have a WhatsApp message from by conclusion of Rutherford display by this is the proving. Also this is the same as what you have also covered. Bisa nk'ibyo tumaze kuvuga hejuru, no problem. Conclusion of Rutherford the nuclear atomic model. Ibi nibyo twavuze hejuru, avugaho electrons ziri hano muri nucleus yaho, protons ziri muri nucleus, aho electrons ziri surrounded. Nuko nguko ingiye ni ntuza ni conclusion yatanze ahangaha. Most space in atom is empty. This proved that the proving model. This ingi ni proving models. Then large amount of atom charges and mass is concentrated into a small region called nucleus. Uvuga ko charge menshi cyane particles ari mu nucleus. This is how Rutherford model explained it. Ahangaha noneho tugiye kureba kuri Thomson. Ahangaha muri ntuzi ibi nabyo biri kuri iyi rig niyo turayivugaho. Tugiye kureba Thomson wavumbuye iki electron akoresheje cathode rays. Thomson ahangaha kuri proving model turacyari kuri ya ntuza ya atomic model. Yavuze ko negative electron were embedded in positive charged spherical cloud. Yavuze ko negative charges hano aya electron gari embedded in yes electron gari embedded in ahangaha dufite positive ziri in the set. Noneho electrons zo ziba ziri embedded twazibonye. Yes, twabonye hano electrons ziba ziri. Yes, I think that you have seen. Then this is the negative electron, yes, electrons ziba ziri negative, you know, were embedded into a positive charge by a spherical cloud. Ziri uburyo buri spherique. Noneho tugiye kureba who discover, yes, who discover electron. Who discover electron? Electron is a negative charge. The discoverer of electron is a Thomson. This is a Thomson. Yes. Hano yes, we are discovering the proton. How? We are going to see it. Conclusion of Thomson. They use by using cathode rays. He found that for background information about cathode rays, anga akoresha cathode ray yabonye form when yes, forms when high voltage is applied across electrode in a partial evacuated tube. Then originate of cathode ray is a negative electrode and move to anode positive electrode. Yes. Then carry energy and can do work. Travel in a straight line in absence of external field. Anga yifashishije cathode rays. Iyo cathode rays yes, yayihaye ntuza ya negative. Yayihaye charge ya negative. Ariyo iki? Anode. Yes. Hano hanga yifashisha na voltage iri high. Yifashisha na voltage iri high. Sorry kutubwira. Then originate the cathode yari ifite negative electrode. Nukuvuga ngo ahangaha ubwo nukuvuga ngo yari afite anode. Yes, afite na cathode. Hano is araza, yes, araza yifashisha voltage, high voltage. Yes. The working air tube yacu. Iyi tube, yes, hano yasiho high voltage. Yes, none hano kuri anode, yes, hano bari kuvuga ngo anode ifite yayihaye positive. Yes, yayihaye positive sign anode. Noneho cathode yahereza negative sign. Then what will happen? Noneho yifashisha iyi cathode rays yayihaye ya cathode rays hano bari kutubwira ngo originate at the cathode, it is cathode in negative electrode. Yahihaye negative electrode. Yes, what is the observation? There is a travel in a straight line in absence of external field. Then we are going to see it clearly in the next slide. By conclusion, by using cathode rays, they found that using cathode ray tube, Thomson was able to deflect cathode rays with electric field. The rays bent toward the positive pole. Yes, angarona ko amarays yagiye kuri positive pole. Yes, twari turi kuvuga ngo no byerekana ko they indicate that they are negative charged. Yes, byahise bigaragaza ko no cathodes ifite negative charges. It means that by using cathode ray, they found that the cathode ray has a negative. This is the experiment I used to discover electron. You know, electron has a positive, has a negative. Yes. Yes. By conclusion, he proved that the atom of element are made with tiny particles with a negative. Yes. Yes, someone atom with negative particles. Yes. And from this, he concluded all atoms must contain these negative particles. Yes. He knew that atom didn't have net charged, so they must be balanced in the negative charge. This is the conclusion. Then we are going to see how to calculate atomic mass. Yes. We use this formula. We take this mass of A times, we take A times M1 plus A2 times M2 plus. This is the formula we have to use when we are calculating relative atomic mass. Use this formula. Yes, over 100. Ahangaha urugero nkangaha turi gushaka relative atomic mass, reka turebe n'urugero baduhaye. Batubwiye oxygen contain 3 isotopes like this and this. Ifite 16, 17, 18 oxygen. then izi ni percentage zayo, oxygen ya 16 ya 17, then ni hano hari 0, sorry hano hari 0.2, yes anga ubwo 0.2 percentage. No bakuvuga ko calculate relative atomic mass of oxygen, anga biragenda biturafata iyi ni abundance, ni percentage, turakubaho ira mass na ira atomic mass ya duteranyo percentage ya kabiri dukubyeho atomic mass, duteranyo percentage ya gatatu dukubyeho relative atomic mass, ugabanije summation, yes ugabanyije ibi ngibi, sorry ibi biraza, izi ni solution, izi ni answer 16, yes 6.0044. This is the answer. Ahangaha urahita uteranya zino abundance, yes nizo urahita uteranya, sorry urahita uteranya zihwana n'ijana buri gihe, nyine ni nkaho ushobora no kugabanya n'ijana kuko iyo biteranyije biba nk'ijana. This is how to calculate relative atomic mass. I think that you understand. For more information, go in the book and read it. Yes, do you understand? Go in the book, go. Yes, for more information, try to go on this page and by using student book to see more exercises about how to calculate relative atomic mass. Then we are going to see the mass spectrometer. What is it? Mass spectrometer is an estimate that are used to separate positive gaseous atoms and molecules according to their mass charge ratio and the record resulting to the mass spectrum. Yes, ahangaha ni estimate igufasha gutandukanya iki sample into yes, that's separate positive gaseous atom and molecules according to their masses and charge ratio and the record resulting to the mass spectrum. Yes, we are going to see it, how it works. Yes, this is the chamber, this is the stages of this mass spectrum. Vaporization, this is the chamber, vaporization chamber, ionization chamber, acceleration chamber, diffraction chamber, detection chamber, and recorder the chambers. These are the stages. We are going to see one by one. Yes, according to the picture. Yes, this is the link you have to go. Yeah, try to search on the link to see the more pictures about mass spectrometer, how it works. Here we have a sample enter here. We have to take a sample and enter here. Then it move to here. Yes, the heat evaporization chamber. Try to heat that chamber. I mean that sample. Sorry. Then after electron beam source. This is the electron beam source. By heating this sample. Then after the sample move in ionized. This they move in acceleration chamber. Then after they move in diffraction chamber. This is in the magnetic. Here this is the ionization. Yes, ionization chamber. This is the chamber 1 is evaporization, chamber 2 is ionization chamber, the chamber 3 is diffraction. Yes, diffraction. Yes, diffraction chamber. Diffraction chamber. The diffraction chamber is the detection. This is the chambers. We have chamber 1, chamber 2, chamber 3, chamber 4. Then the last one is the recorder. Yes, the recorder will move here. The recorder is the last chamber. The recorder, the last chamber. Then the result will record in this form of mass spectrum. This is the spectrum in the form of spectrum. Yes, I think that you see how this mass spectrometer works. And yes, I think that here we have first of all the sample we move here. We start from the sample. We take the sample and we enter here. Then the sample we move in this chamber. The first chamber is called the vaporization chamber. Here the sample will be heated by using this electron beam source. Therefore, this sample will move in this chamber, the second chamber called ionization chamber. Here in the ionization chamber, the sample will have the positive charge, means that the mass spectrometer works with that positive charge only. Then after the charge, this charge will move at high speed with a constant velocity. to go in this the third chamber is called the diffraction chamber. In this diffraction chamber we use this magnetic. You see this is the magnetic. This magnetic field deflect released ion is most, means that if the sample is heavy, the diffraction is released. If the sample is lighter, diffraction is the most. Anga bishaka kuvuga ko iyo sample yawe ifite iremere mbega ifite mass iri greater, diffraction yayo igenda gake. Anga ifite mass ntoya cyane, diffraction yayo igenda byihuse cyane. Diffraction yingiye ukoresha magnetic field. I think that you understand. Then after this chamber, this charge will move. According to the C, you see this is the friction. This is the friction. This is the field. Here, they deflected on the detector. This is the fourth chamber is called the detector. Here, this detector, it depends with, when you are detecting this mass, we use this, it depends with the mass over charges. Mass over charges. Example, if you have sodium, for instance, sodium has positive charges. Here, you know, sodium has an atomic mass which is 23. Means that we are going to take this 23, yes, over charges. Charges is 1, will be equal to 23. This is the detection depends on this mass over charges. Also, for instance, if you have let us take example magnesium. Magnesium has a 24, yes, atomic mass. Then what about the charge? It is yes, it is 2 plus. Then we are going to see, yes, mass over charge ratio. We take a mass over charges, yes, over charge ratio means that we are going to take this mass 24 over, yes, over 2, yes. We'll have 12. Then we are going to compare the mass, this mass. We are going to compare this mass. Here, sodium has a mass of 23. Also, magnesium has a mass of 12. Then we are going to deflect it. Anga urabona ko sodium ifite mass ya 23 wonye ukuntu twabikarikiriye. Anga magnesium ifite mass ya 12. None anga rero tugiye kuzishyira mu icemba ya gatatu ya deflection. Anga kuko iri heavy mass, iyi ngiyi iraremereye. Heavy mass deflection yayo irabaga kiya cyane. Kuko iyi ngiyi ifite mass ya 12, deflection yayo irihuta cyane. This is how this magnetic field deflect the lightest ions. Example anga niba tugiye kudeflectinga sodium na magnesium, ifite lightest ion araba magnesium. Ahanga iraba niyo mpamvu how deflection yayo iraza kuba most. For this sodium, deflection will be yes, because it has a greater mass. Deflection is the least. After this deflection, we will go in the chamber called the detector. In the detector, they depend also on the mass over charges ratio. After detection, we will go in the last chamber is called recorder. In the recorder, this is the last chamber is called, and this is the five chambers. Recorder, this recorder, ahangaha nuvuga ngo iyi recorder ibicometse kuri computer. No computer ibigaragaza ira printing aho nk'urupapuro rukariho, runo rupapuro rukariho zino spectrum. Urabona izi spectrum ni peak. Ahangaha twa dufite iyi element, yes, ino element urabona ko yagaragaje ama peak atandukanye. Iyi no hano ni kuri abondance biba bisaba kuba iri kwijana. Reba peak ya mbere yajigera kuri 50, abondance percentage 50. Ya kabiri iraza ahangaha ugashyiramo interval. Yes, ahangaha urabona dufite 50, 40, 30, 20, 10, 0. Bigaragara ko ahangaha urabona ko ahangaha iraba iri ku 10. Then also here we are on 10. For here we are about to 20. Ahangaha urukona ko naho byenda kwegera ariko ntabwo 70 izi ntuza izi ni spectrum arizo bita n'amapiki cyangwa also isotopes. Hano dufite how many isotopes we have? 1, we have 2, we have 3, we have 4, we have 5. Ariko urabona ko abundance zazo zigiye zitandukana. Ni ukuvuga ngo uko zagiye zikora deflection hari yagiye cyane yabaye deflected. Urabona yageze kuri 90, yageze hano kuri 50. Hari yagiye gake cyane igera hano hagati kuri 30, yagiye hafi n'10, yagiye hafi no kuri 5. Ahangaha biba byatewe n'iki? Biba byatewe n'iyi mass over charges ratio. This is how the mass spectrometer works. I think that you understand. This is mass spectrometer. For more information, go in the book and read it. Yes, I think that you understand. Let us continue with the next slide. Also, this is the same. I think that I try this is the same. I think that we have also explained where we have the vaporization sample. The sample will go in here. Then this is the second chamber ionization. After we are going to be these charges are going to be accelerated. Therefore, this you have electromagnetic, and in the electromagnetic there is a diffraction. Also, after diffraction, we will go in the detection. This detection will go in amplifier. This is the after this amplifier it act as a recorder. Ahangaha bikorana recorder na amplifier bijya gukorana kimwe kugira ngo za ntuza za spectrum zize kugaragara mu buryo buri in form of peak. Ahangaha bigeze ahangaha biba bisanga ufate ino detection. Yes, uyicomeke kuri ntuza ukimara kuvanga kuri detection ujya ahangaha ku amplifier. Ahangaha ni mu buryo bwa computer biba bisanga ngo ibicometse kuri computer kugira ize kugaragaza ya spectrum akagaragaza in form of peak. Yes, I think that you understand. Also, no time to lose about it. This is also they are the same. You have it in your free time. Try to read it. Try to see it. Try to play these videos. You will understand. I think that I try to explain well. Yes, no time to explain for this. You understand. These are the pictures about the mass spectrometer. Yes. Also, yes, in detail, we are going to explain clearly all stages of mass spectrometer. I think that the chamber one is vaporization. The sample is heated and become lower vapor pressure. Yes, ready to go in ionization chamber. Yes, this is the meaning. First of all, the sample is heated. After heating, they have a lower pressure. After they go in this is the first stage. This is the second stage called ionization chamber. What will happen in the ionization chamber? In the ionization chamber, the sample are bombarded with electron gun, and some collision are energetic enough to knock one or more electron out of the sample, is to make positive ion. Akuvuga ngaha ni iki kibera hano muri ionization chamber. Nuvuga ngo habo iyi sample iba bombarded. Nuvuga ngo uzana ntuza ama electron guns. Noneho ayo electron guns ukayabombarida cyangwa ukayashyira kuri ntuza kuri sample. Noneho wamara kuyashyira hakabaho hagahita hasohokamo ama electromesh. Yes, ama electromesh rero mu yasohokamo icyo tuba dukeneye twebwe tuba dukeneye positive niyo dukorana mass spectrometer work with positive. Izi positive, iyi positive yabonetse ni igiye kugenda igiye kujya muri chamber ya gatatu ariyo acceleration. Iyi acceleration ubwo iyi positive yagiye muri acceleration chambers. What will happen about in acceleration chambers? This positive ion, yes, are accelerated by electrical field. Ahangaha bikorana electrical field. You know, electrical field have a positive and negative, whereas magnetic field has magnetic field. I think that in physics you studied have north and south. Yes, has north and south. Then here in acceleration chamber, the positive move are accelerated by electric field, so that they move rapidly with flow machine at high and constant velocity. This is what will happen in the ionization chamber. After these three chambers, we are going to go in the fourth chamber called diffraction. What if you understand diffraction? Immediately you have to understand mass. Yes, mass over charge relation. I think that in the previous slide we have discussed about this mass over charge relation. What will happen are deflected by magnetic field. This is the magnetic field according to the mass over charge ratio. Yes, according to the mass over charge ratio. I think that the heaviest ion is deflect is the least, whereas the least the lightest ion is deflected the most. I think that I explained in the previous slide. In order to understand, we try to play the previous slide to understand. Also here we have the factors that depend on diffraction. What are them? We have the electrical field strength, magnetic field strength, and mass of particles, yes, and charges of particles. These any factors muri diffraction is intuza diffraction depending kuri electrical field. Ifite strength electrical fields birasanga diffraction nayo irihuta. Ahangaha ifite magnetic field ifite stronger diffraction irihuta. About masses and charge, uvuga ngo ifite mass ntoya cyane diffraction yayo irihuta, iraba most diffracted. Ifite mass nini diffraction yayo iraba least. And charges also, wabonye twari dufite sodium. Yes, we have a sodium with positive charge, and also magnesium. Yes, magnesium has 2 charges. We have seen this have 23. Yes, 23, and for magnesium it is 24. Then we are going to take this 23 over 1. Also, we are going to take this 24 over 2. This is the mass over charges ratio. Ahangaha umaze kubikarikira uhita ureba ifite mass nini cyane n'ifite mass ntoya cyane. This is how the diffraction chamber. Those are the action that are occurring in the diffraction chamber. I think that you understand very clearly. For more information, go in the book and read it. Yes. Also, I think that is the 5. I think it is the 5 stages called detection. How are detected by electrically. Yes, if you understand electrically, means that you have positive and negative. Yes, remember mass spectrometer work with positive only. Then the more detected is due to less diffracted. Nuvuga ngo yabaye detected nuko yabaye less diffracted. You understand? You have detected and diffracted. Diffracted ko yabaye less diffracted nuko yabaye more detected. Bishaka kuvuga ko yabaye less detected iba more diffracted. You understand? By using small magnetic field, and to detect a large mass, you would have to diffract them more. Kugira ngo udetecting ifite mass nini cyane, birasaba kwikora diffraction. Yes, inshuro nyinshi cyane, mbega ukayikora diffraction cyane by using large magnetic field. You understand? As the last 6 stages is recorder. This recorder, yes, I think that the results are recorded in form of spectrum. This is the abundance. This abundance, yes, should have abundance should the maximum is 100. Ahangaha ni ukuvuga ngo yes, peaks ahangaha bigaragara aya ni ama peaks gaza kuboneka. Yes, gaba gatandukanye bitewe na kuko na masses zatandukanye ahangaha muri diffraction chambers. This is the recorder in mass of spectrum peak. Ahangaha ibayabonetse ahangaha uraza ukareba tuvuga ku iyi peak ya mbere birashoboka ahangaha kadufashe nk'urugero tufite ahangaha kari kuri 50. Iyi ngiyi nayo ushobora gusanga hano nko kuri 49, iyi ngiyi ikaba iri nko kuri 30. Ahangaha urestima ntabwo ari ukuvuga ngo uraza ukajya westima ukajya ureba ino peak. Yes, ahantu iri ahantu yagiye igarukira ugendeye kuno kwi abundance. This is hano ni mass over charges. This is how recorder works, the result of record. Also, the last topic you have to know is the function of mass spectrometer. The function, we have 5 functions. First one is geological, during oil production composition, and we have biotechnology, we have clinical, during drug testing, also pharmaceutical and environmental in water quality. This is the uses of mass spectrometer in our daily life. This is how this is the end of this session. We end with the homework. Try to go in the page 20 and try to go this checkup 1.5 by using student book. Try to do this question 1 up to question 6. Then try to do this. This is the exercise. This is the homework you have to do. You have to do it in your free time, and you will submit. This is the last point, and this is the end of this side. Thank you for your kind attention, and God bless you all.